Hey, this is Steven from RC Engineering, and today we're going to be going on to our next series, our next video of the development series. So what I did is I just today filmed the first part of part 3 of the brush test stand, and that will be coming out next week because I need to print. I'm going to print those guys out on my Trinus or Cetus. I have a Trinus and now I have a Cetus 3D printer as well. I have the Cetus Extended. Actually, I have two Cetuses. I have the Cetus Extended and I have the Cetus Standard. So what I'm going to be doing is I'll be printing those next week or this coming week, and then I'll assemble it, and then I'll show you guys a video of the assembly and also what I've changed and stuff like that, and then hopefully this week we could do an analysis video on that to do some testing of some motors we got from FPV headquarters. So let's go ahead and get started. So today we're going to be doing a new video for something that I was really interested in trying. I wanted to do a car, sort of like a car thing, that because what we're going to be doing is we're going to be progressing into more and more mechanical things. So we're going to kind of be progressing forward and forward and forward. I mean, it's been a big jump into the development of the thrust stand. It's more of a static type thing, structural load, very interesting. And also I should probably be doing a static analysis on it. That's probably what I'll do in another video when I don't have one for the analysis in the month, is to look at running static analysis in Fusion 360. That's definitely something I should do. So basically we're going to keep progressing in the difficulty of the design to where eventually we're designing our own machines, cars, boats, planes, helicopters, quadcopters, stuff like that. So we're going to continue to increase in complexity until we get to that point. So what we're going to be doing in this video is we're going to be doing something that I think quite a few people will want to use, and especially with this upcoming year, Flight Fest coming, hopefully to California again, the West, because they've had East, South, and West, and hopefully they come back to the West. Hopefully they find another location and they come back to fly out here. For that, I wanted to get something that might help some newer users that have newer pilots that have more expensive planes, that want to have a cheap alternative to hand launching. So most of their plans, and a lot of planes nowadays, flight test plans, are hand launch systems. And the problem with hand launching is, especially with faster planes, the large rotating mass that causes p-torque, which means that the plane rolls to one side. So that's very difficult, especially if you're throwing it by yourself, because you momentarily have, or sometimes you never do, you have one hand off the controller, and generally you're throwing with your right hand, which is all your control, and your left hand is down on the throttle, because I'm right-handed, right? When most people I see throw it that way. However, left-handed would be definitely a better way, because generally you keep the throttle at one level and then you could have control. But still, I think that's a little that makes people a little anxious, especially when they're starting out with their maiden and the plane might be a little iffy, and they want to just kind of test it out before they are comfortable hand launching. So, and obviously those fail in comparison compared to a plane with a landing gear, but that's not always the easiest to attach. And also we could have varying size of terrain that we have to go across. So and also the drag in the air, because generally those types of planes, the foam types of planes, they don't retract, so you have all that drag also. So you have lost speed, loss efficiency, and obviously because of those two, lower flight times. And for me, most of my planes that I do like that have problems taking off are fast planes, because generally planes with landing gear, they have, if they're smaller, they have decent takeoff speeds. For example, here on the wall in my office here, I have a I have a high-tech zipper and a high-tech E-Hawkeye. Both of those have no problem taking off, like barely any throw at all. I just kind of throw it up at like 75 degrees, and they just flatten out and take off. Same thing with the glider, and the reason being is their pitch to diameter ratio. If you saw my rule of thumb series on intro to propellers, if you have a 0.5 pitch to prop ratio, it's way the plane has way more thrust out of the start, which I believe the E-Hawkeye has a 6x3, so that is a 0.5, right? Perfect for static thrust right out of the hole, with no forward velocity. However, the zipper has a 4x4, which is a 1 pitch to diameter, and the one that I mainly have a lot of problems launching by myself. Launching with another person is a whole different story, but launching by myself, that one is a handful. It's the T-28, that Trojan, that I'm uploading the review to right now, because it's the 4th of February, which is one of my upload days, and today that review is going up. So that guy is a handful to hand launch by myself, because of the momentarily taking your hand off of the throttle, off of the sticks, causes your plane to, it causes you to be unsure about your plane, and a lot of anxiety, right, to crashing your plane. And I've already crashed it once from a bad toss, especially on something like a 4-cell setup where the plane's even heavier. You have a very, very aggressive 1-to-1 pitch, and it's very, very slow out of the start. So you have to get some speed going over the prop to get it to do anything. So yeah, that I cracked in half one time because I gave it a bad launch. So the idea is to alleviate that anxiety for some people that want to mate in their planes and they don't want to destroy them. Some people that have more expensive hand tossing planes. For example, the EFX Racer from Hobby King, from I believe this Durfly. I think it's Durfly. Anyways, that guy is a decently expensive hand launching plane, and probably a lot of anxiety starting out first launching that plane. So I want to just kind of alleviate that to where you're not as worried about hand launching it. What we're going to build is we're going to design a 3D printable truck, like a little takeoff piece. Let me see if there's anything like that. It's like a takeoff. It's like a detachable takeoff like carriage thing. Yeah. So here's like a good example. I mean, it's not a very good example, but it'll show you what I'm talking about. So here you could see it's basically got this large platform with your plane. Obviously a very large plane. This is going to be very difficult to launch by yourself, because you have to put so much effort into launching it and then bring your hands back down to the controls. And if you're throwing it with your left hand, which I probably should start practicing, is launching with my left hand, so I could have constant control over the rudder and elevator, or the ailerons in the elevator. This is going to be very difficult to self-launch. So this is a good example for what I'm talking about. So this is what we're going to be building, but obviously way smaller. Here's another view of it. Let me bring that up if I don't find anything else. But it's going to be very interesting because it's also kind of like a car. So we're basically designing the chassis of a car. And nothing says that it can't actually be powered as well. So here is another version of it. So you can see here the big legs and this guy here. But what we're going to be looking at is maybe a smaller a 6x6 for because now my Cetus has a 6x6, so I can only do a 6x6 truck. But that's perfectly fine for fun fighters or smaller airplanes, or most of Flight Fest's lineup. It will be able to run on this guy. But wood is perfectly fine too. And you see, this is basically for balance. This being out here like that. That's basically for stability. You can see it's basically landing gear. So what happens is, as this guy comes up to speed, it just lifts off out of this here. No worry about crashing and breaking this thing in half or breaking a prop off. This I'm not as worried because it's got foldable props. But on my Trojan, it's got an APC prop. Every single time I break that prop, I lose $2.50. Need to go buy another one from Aeromicro. And then obviously another $3 in gas, $4 in gas up and back. So not very good to have that happen. So a small little takeoff thing, not for something this long, something smaller. Even though these are where we get more trouble. But I have an idea for another design for a powered launcher. But that will be more advanced design further down the line here. We'll work on that. So this one, we will be doing this out of plastic limitations. So let's talk a little bit about our limitations. 6 inches by 6 inches, the build volume of the Cetus. And also we have 8 inches tall or so, 8 or 9 inches tall on the Cetus. And made out of PLA plastic. And we're going to be interacting with other types of materials in this one. We're going to be interacting with bearings, shafts, wheels, way more than the other one. Way more than our last series where we only interacted with motors and a bolt, which is a shaft. So this one we're going to have wheels, axles, multiple prints probably that come together depending on complexity. Maybe even some supports, stuff like that. But I think that this will be very helpful for the community and available for most people with 3D printers, especially now with kits being so cheap. Print something of their own so that they can use their flight test models or other smaller planes and be able to take off. And again, if you have a model like this, you could just print 2. One for up here, one back for back there. That's perfectly fine. You could have 2, and then maybe put a piece of wood shaft between the 2 to attach the 2 together. That's fine. It's no difference. You're just gonna need more material. So this should be scalable to pretty much any size plane. You just might need multiple of them. So one here and one back here, just like how it has it here. It has 2 wheels up front, 1 wheel on the back. That's fine. Okay, so let's go ahead and look at a sketch. Let's do some paint, and let me see if I could do a decent paint job for you guys here. So obviously square chassis here, or rectangular chassis, right? And we're gonna have 4 wheels as far apart as possible, give us as big of a base to support that plane as possible. Sorry, my cat's getting really verbal. It's almost nap time for her. So here we go, shaft through, bearings. Gonna have some bearings in here to take the load. Maybe one, depending, maybe 1 bearing. Try to go 1 bearing, make it cheaper. Singular bearing. Maybe a 608, standard, easy to find. Maybe smaller, make the print smaller. And then we're gonna have some forks, or I'll figure out a way to put it in there. What I'm probably going to do is have like a slope a standard slope that will fit most planes. So instead of having a fork like this other one did, have a slope, so most planes will pop down in there. So have a slope there, a slope across here. So this is a front view, this is top, and then this is the side, so have a slope like this, right, where most planes will fit inside that slope somewhere. And then maybe somewhere in the middle here, have a piece that comes out like this at a 45, so that eventually it'll hit the wings at some point. I don't know if I can make that adjustable or something. To try to hold the wings up. And then again, also another thing for this guy, obviously it comes off. So when the plane takes off, it lays there on the floor, and then you go pick it up and take it off again. So you don't have to worry about a landing gear or the weight of the landing gear, because the landing gear just stays on the ground while you take off. And then when you're ready to land, you land in the grass or whatever. So you don't have to worry, if you're flying a fast model, you don't have to worry about breaking your prop. You don't have to worry about breaking your plane in half on takeoff. And you also don't have to worry about the retract weight and also the wind drag, so you could fly fast and more efficiently. Another thing being also, I would like this height at least. So let's say this here or whatever, and we have wheels here. Let's say I want this height from the center down to the ground to be at least 4 inches or so, because I'm running on that Trojan, which I would really like to use this for testing. That is a 5-inch prop, so 5-inch diameter, so that's 2.5-inch radius. So this will accommodate an 8-inch prop, which most high-speed planes won't have. You have something like the EFX Racer has, I think, also a 5x5 or a 6x3 or 6x6 or something, so that will fit in here. Because I do not want the prop hitting the ground when it's rotating, so obviously that's another major consideration. And then here would be a bearing somewhere in here with a shaft that goes across. And then obviously be able to handle maybe up to 1 pound, 1 pound of downforce on this guy without breaking. Alright, so that's the idea, and printed as few pieces as possible. Maybe this guy might be bolted on here, so you could swap this guy out just in case that doesn't quite fit, or we have 2 options with one where it's connected and one where it's not, or where you could design your own piece and then plop that guy on there and then be perfectly fine. So if you do have a 3D printer and you do know how to use something like Fusion, you can go in there and change this to be however you want. Alright, so anything else? I need to figure out where these wheels are going to come from. Maybe foam wheels or something. Maybe laser cut foam wheels. And then what I would like to do is make this quote-unquote product available for people that don't have a 3D printer that want to pick it up for slightly above cost, and then that would be pretty cool. Alright, so yeah, basically, so 1 pound, it's got to obviously be smaller than 6-inch by 6-inch, which I would like to push. Obviously this is not going to be best for most beds, but most beds are around 6x6. Really small, that's pretty average size. So let's go ahead and do that. And I'm pretty sure this is a 6x6. Actually, it'll print a little bigger than 6x6, but that's what we're gonna go for. So standard for pretty much most printers, 6x6 by 9 inches tall or so, but we're not worried about that. Fit 1 pound, work certain types of bearings. I'll come up with certain types of bearings before we go into the second video of this guy. Alright, so let's go ahead and get started. So here, first thing we're going to do is we're going to save this as the hand launch detachable carriage. I'm going to do a piece down here. We're going to keep it in inches. And first thing that we're going to do is we're going to draw our 6" by 6" capacity. And we're going to go draw across, make sure everything's construction line. There we go. And let's go ahead and we're going to do a rectangular truck. Oh, you can do a square truck. But we want to be within this, guys. So let's say we're going to do 5" by 5" to give us some leeway for right now. Alright, so there we go. So let's make this the bottom. And so what we'll do is, starting out, we'll make it so that we have the top piece bolts down or something. So first thing that we're going to do is we're going to do an offset on the inside here, and we'll come in about 1/4 inch. So we want to maintain some rigidity. And then what we're going to do is we're going to do some lines inside here about as close to the edge here as possible. And then we're going to, this will be the start. And then inside here, let's see, oops. We're going to look up 608 ZZ bearings and look at some of the details on those, some specs. And those are standard skateboard bearings. They have an 8mm bore, so that's a nice strong, it's a little bit over 1/4 inch shaft, which should be fine for pretty much all. This might be a little overkill, but they're very, very easy to get a hold of. 22mm outside diameter, so we need at least a 26 to 30mm diameter of whatever you put in here. So let's say from here to here we're going to do 15mm. So that would be the center of the box. So let's take a look at what we're looking at here. So this guy is says here that it is at least thickness, width 7mm. So let's say that that's 7mm. And then this guy is we're gonna say like 30mm. Okay, so there's our block. And we're going to do the exact same thing on the other side, but you can see this 1/4 inch here. Maybe we can do get really, really close, or maybe right on. But let's roll with that. Okay. So let's do this. What? There you go. Okay, then this is going to be 15. Center point rectangle. This is 7mm. This is 30mm. Alright, so there's our two bearings. And as you see, we're definitely pushing the sides. Now that I think about it, this we could push probably to the extents total. So let's go ahead and do that. So let's go ahead and push this as big as we can get it. Nice big stance, not worried about the plane tipping over. And this guy I'm sure could do over that. Let's see, Cetus, build volume, Cetus 3D. It's talking about Chinese New Year, which yes is upon us, Chinese New Year. graphics. Here we go. Extended version 7 by 11 by 7. So we have a 7-inch build volume. Nice. Okay, so let's look at that. So let's change this to 7. That's oop. There it goes. Okay, so 6 by 6. Alright. So I got a little bit better base here. These are big bearings, but the interior center of the bearings are 8. It's an 8mm center section, so it's still kind of a small shaft, but decent size balls in there. Dynamic load 3,297 newtons, which is massive. Static load 1,368 newtons, which is also massive. So maybe we could find some smaller bearings there, especially to make it lighter weight. So kind of, well, we kind of want it still to stay down on the floor and not get stuck to the plane. We'll take a look at that when that comes. Okay, so we're going to start out with this guy, and we're going to have it come up and out. First we're going to do, let's do first this guy and leave that guy. So let's say that this is going to be at least 1/4 of an inch. For strength, I'm going to go in, turn back on that sketch. I'm going to do the next one here, and this one's going to be 0.25, and I'm going to say plus 0.125. So this is kind of like a little spine, just kind of adds stability, and we'll also add some stuff here. So now another thing that we need to do is we need to do the extrude here. So this is 0.25 plus 0.125 plus, it needs to be at least 30 millimeters. Okay, so let's now do a drawing. What I'm going to do is it needs to be up to this point and up to this point. As you see, these bearings are going to be massive. So might not, because we want still a pretty low center of gravity, which is not going to be beneficial here. So we might need to change our bearing choice. That's okay. We'll take a look at it right now. Okay, so we're going to do a circle, center point. This is 0.2 millimeters. For right now, obviously we would need to do adjustments, so those guys press fit. Close that out, extrude. You see here our problem, why I didn't make those construct lines. These here, make these construct lines, otherwise it'll make your life harder. And then stop that, hit extrude. Cat's getting anxious. Cut. And we want to cut this way. Cut through. Alright, so there we go. And then we could add a little bit of a support here, inside rib here, to take a look at the stresses on that guy. Alright, so that would be for this guy. And then in the next video, we'll add the top portion and the bolt holes where you would bolt that guy down, so that guy would come across here, right? And then it would hold your plane up while it was driving. And then we're going to look at drawing out these bearings so you can take a look at them. And then we'll build a big assembly of putting those together and what it would look like. So that will be in the next time we do this one. I think the next week I'll be doing, I'll be finishing off, what's it called? I'll be finishing off doing the thrust stand, so we can do some tests on that, and then we'll continue with this guy when we're done with the test stand. So I would really like to use this guy here in the coming few weeks, because I'm going to be back doing 4S, and not every time that I'm going to be out somewhere will I have somebody that is willing to hand toss my planes. So currently I have Maurice and Carlisle that are generally out there. Maurice at least is pretty much out there almost every time I am, so I can get a hand launch from him. But if he's not there, I would like to have this dolly or carriage to help me get off the ground, so I don't have to worry about gluing together my plane, because they're big investments for me to buy planes, and even though most planes I get on the channel are on a budget, it's still, that's not exactly the same for everybody. So I want to help those people out, because they could be putting a couple $100 into their belly lander investments. So I want them to be able to have something that is cheap and easy to use, that they don't need to have a slingshot or anything like that, which we'll go over later. Building a complex active or powered system, which is going to be really, really cool. So this has been Steven from RC Engineering. If you guys like this video, please subscribe for more videos like it, my development and general series. If you guys like what I do, go ahead and check out my Patreon. Also on my Patreon, link is in the description, of course. Also on my Patreon, I am trying to post more and more free, exclusive content on my Patreon. So go over there and check out some of the free content, and also my rewards for my Patreon backers to back my channel. And basically, the more people back, the more content I will develop, and the more rewards, etc., etc. Alright, so this has been Steve from RC Engineering. Thanks for watching. Catch you guys later. Take it easy. Peace.